Hello friends, welcome back. Today in this video we will be working on a new sensor which is an analog to digital converter, and that is MCP3426. So for more info about this sensor, let's go to controleverything.com and here search for our sensor, that is MCP3426. Here it is. It is a 16-bit 2-channel analog to digital converter, and some of its more important features are mentioned here. You can also buy this sensor from here. Today we will be interfacing this sensor with a BeagleBone Black and a C code, and for that the main requirement is of a code. So click on Resource tab and here you will find the C code sample for MCP3426. Click on it and you can download all the code from here as a zip file. You can also have the same code from our GitHub repository, which is Control Everything community. Now we need some hardware for interfacing this sensor, so let's move to that part. In hardware connections part, first thing we need is a BeagleBone Black, and this here is an I2C Shield for BeagleBone Black. The shield is available on the website controleverything.com and you can purchase it from there. The reason behind using this is to make connections with other I2C devices very easy. So gently place this over the BeagleBone Black and make a connection like this. Now to power up our BeagleBone Black, we have to do two things. Firstly, we need a mini USB cable just like this, and we have to insert it in the power jack of the BeagleBone Black. The second thing is we need a 5V adapter. We have to insert it in the power jack of the I2C Shield. Now in case you want to provide an internet connection to the BeagleBone Black, you have two options. You can use a Ethernet or LAN cable, or you can use a wireless nano USB adapter and insert it in the USB jack of the BeagleBone Black. This is our sensor MCP3426 and this is a connecting cable. Connect the sensor with connecting cable like this, and while making connection, make sure the brown wire of the cable should be connected to the ground of the sensor. And the same rule applies to the I2C Shield. And with this, we are done with the hardware part. Now let's move on to the interfacing and working of the sensor. For the interfacing part, first of all we have to log into github.com, and here we have to search for the repository which is Control Everything community. Click on it and here search the sensor MCP3426. Here is our sensor and this is the C code. But first let's go to the instructions we have to follow. We have to set up our BeagleBone Black and all the relevant steps are given on BeagleBone.org link. Please go through this link and do it very carefully. After that, this is the command for compilation of the program and this is the command to run the program. We are done with the instructions. Now let's get back to the code. This is our C code with .c extension. Click on it and here is the code. Firstly, we have included some of the header files here, and in the void main we have created the I2C bus device here. Now we have to get the I2C device address of MCP3426, which is 0x68, and we have done that part here. In the writing section, we have selected the configuration command 0x10, in which we have selected continuous conversion mode, channel 1 and 12-bit of resolution. After that, we have given a delay of 1 second here. And in the reading part, we have read 2 bytes of data from the register 0x00, which is raw ADC MSB and raw ADC LSB. And then we have converted the data to 12 bits according to the formula given in the datasheet of MCP3426. And finally, we have output the data to screen through printf command here. With this, we are done with the interfacing of the sensor. Let's move to the working and see how it performs. Now for the working part, first of all we have to copy the entire C code. And then we have to open the terminal. We have connected with the BeagleBone. Now we have to create a new file with MCP3426 with .c extension. Now we have to paste our code here and then save it. Now for the compilation of our program, this is the command which is given in the instructions, and now our code is compiled. So now let's run our program. This is the command, and you guys see the raw value of the source is now 0. Again running the code, it is 0 because nothing is connected to the channel 1 of the sensor. But when I connect a 1.5 volt of AA battery to the channel 1 of the source of the sensor, the output is now 850. On again running the code, the output is same because the battery is connected to the channel 1 continuously. So this is how the our sensor works. Now let's move to the application and features of this sensor. The sensor is a 16-bit analog to digital converter with differential inputs. It is a low noise and high accuracy 16-bit delta sigma analog to digital converter. It is the family member of MCP3426 series from the microchip technology. The device can output analog to digital conversion results at rate of 15, 60 or 240 samples per second depending on the user controllable configuration bit settings. The device have two conversion modes, one-shot conversion mode and continuous conversion mode. The application includes portable instrumentation and consumer goods, temperature sensing with RTD and thermocouple, bridge sensing for pressure, strain and force, weigh scales and battery fuel gauges, factory automation equipment and many more like this. This sensor can be purchased from our website, that is controleverything.com. You can download the code from resource tab and after that as a zip file. Also, you can have the code from our GitHub repository, which is Control Everything Community. In the end, I would like to clear, if you have any further queries regarding the interfacing and working of the sensor, you can reach us on controleverything.com and you can also post comments on our community page. For articles and blogs on various sensors like this, you can look us on instructable.com and you can subscribe our YouTube channel for more video tutorials like this. In the end, I hope you enjoyed the video and have a good day.